In this video, we are going to begin our discussion of addition and subtraction, and we are going to start by looking at some of the standards in the South Carolina State Standards, and then we're going to continue on to some properties that your students need to be familiar with before they begin learning and memorizing their addition and subtraction facts. So first of all, let's look at some South Carolina State Standards. I went through and cut and pasted the ones that were relevant to what we're doing today. And what I want you guys to see is kind of the progression of how students move through the standards. So in kindergarten, notice that they're doing a lot of modeling, they're doing a lot of physical things to help them learn. They're solving story problems. Most of those are going to be verbal because these kids are just learning how to read. And they're finding sums up to 10, differences within 10. So that means they're learning things like 5 plus 5 equals 10. But they don't yet have to have that memorized. They're just learning how this works. In first grade, they're going to up that to 20. So now we're learning things like 6 plus 7 and 9 plus 5. Still doing story problems. Now we're going to be adding 3 numbers. And the reason why is because in second grade, we're going to start regrouping. So we need to know what to do with when we have 3 numbers instead of just 2. Looking at the commutative and associative properties. And also notice now we have fluency. So that means they have these particular facts memorized. As we continue to move forward into second grade, look, now we're doing 1-step and 2-step story problems, and we're going up through 99. We have fluency with all of our single-digit addition and subtraction facts, so now we have memorized them. We learn what they mean in kindergarten and first grade. By the end of second grade, we should have those memorized. Third grade, now we're going up through 1,000. Nothing new about what we're doing with addition except for the size of the number. And then in fourth grade, we're able to do that fluently. We can add any 2 whole numbers that are given to us, no matter what the context is. Okay, so in order to help our students through that, let's look at some properties. So first of all, the closure property. Now this one may be unfamiliar to you. Closure may be a new property. Basically, imagine that all of your whole numbers are in a room with the doors closed. Okay, so first of all, we need to know what the whole numbers are. The whole numbers are the positive integers and also 0. So we're looking at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, ... No fractions, no decimals, and also no negatives at this point, focusing only with our smaller students on whole numbers. So I've got all my whole numbers in a room with the door closed. And what this is saying is that if I add any 2 of the numbers in the room, I'm going to get another number that's already in the room. You can't get out the door because it's closed. Everything you need is inside that room. So what this closure property implies is not only that that number exists, that it's in the room, but also that it is unique. 5 plus 2 only equals 7. 5 plus 2 doesn't also equal something else. And 7 is a whole number that's in the room. So that's the closure property. All right, so if I subtract, if A is a number less than B, then A minus B, this says it's not meaningful in the set of whole numbers. Basically, the answer that you get is a negative number, which is not a whole number. The whole numbers are the positive integers and 0. So subtraction is not closed. All right, so what that means in a less technical sense, suppose that I have some numbers and I have the numbers 4 and 8 in my room. And 4 and 8 are whole numbers. But if I subtract them, the number that I get is -4, which is not a whole number. So therefore, the whole numbers are not closed because when I subtract those, I have a number that's outside of the room. I have to open up the door to get a new number. So it's not closed. All right, so let's look at a set here. What are some other numbers that might need to be included in order for this set to be closed? Well, let's see. 4 plus 7 is 11. That's not right there. So let me add 11 to that set. 4 plus 12, well, that's 16. I need to add that. But then I also need to go back and add like 4 plus the 11 I just put in the room. So 4 plus 11 is 15. 4 plus 16 is 20, and I'd have to add 4 to 15 to get 19, and my list would continue. I'm not saying, and when you get these questions in my math lab, it is not saying that this is all the numbers you need. just saying that this is some of the numbers you need. The set that I have written is not closed because there are other numbers that need to be in there. Okay, a number that doesn't need to be in there is 3. I cannot add any of these numbers and end up with 3. So I don't need to add 3 to my room, but these numbers I need to add. All right, same kind of thing down here. Do I need to add the number 3? Well, this time I do, because look, 1 plus 2 is 3. So 3 should be in the room. How about 0? Do I need to add 0? No, because there's no way to add any of these numbers and end up with 0. 4 plus 2, well, that's 6. 6 should be in the room. 1 plus 9, that's 10. 10 should be in the room. So any two numbers, the answer that you get when you add them needs to be in there. And numbers that I cannot get to, like in this case 0 or in this case 3, they don't need to be in the room. All right, so you guys think about this. Are all even whole numbers, if I have that as a set, all the even whole numbers, is that set closed under addition? Put some numbers down on a piece of paper, experiment with that a little while, see what you get. All right, hopefully you got that the answer to that is yes. If I add any two even numbers, I'm going to get an even number. So therefore, the set of even whole numbers is closed. So how about odd? Does the same thing work for odd? Do some experimentation. I hope you found out that the answer is no. If I add two odd numbers, I get an even number. 5 plus 3, for example, is 8, which is even. So therefore, the set of all odd whole numbers is not closed under addition because I can add them and I can get something that's not already in the set. I had to go, quote unquote, outside the room to get my answer. Okay, so this is one you probably are very familiar with. It's the commutative property. Commute, the word commute, means to move back and forth. A lot of you guys are probably commuter students this year. So you live in one place and you drive to school. That's a commute. You go back and forth. So that's the same thing with the numbers. The commutative property says the numbers can move back and forth. Here I have A in front of B, and here I have B in front of A. So the numbers have moved. They've changed places. One thing I want you to be very careful of, look at the spelling of this word. Do you guys see that T right there? This is the commutative property. It is not the commutative property with an N. The numbers are not talking. They are not communicating back and forth. They are moving. They are commuting. So please make sure you spell that correctly. Make sure you pronounce that correctly. Your students will understand this property better, actually, if you are more precise with what you say and how you spell. So here is a number line diagram demonstrating that if I add 3 and then 5, or I add 5 and then 3, either way, the sum turns out to be 8. Same thing over here with a strip diagram. I can see that 3 plus 5 that I have on the top and 5 plus 3 that I have on the bottom are the same. Order does not matter with addition. All right, the associative property. Think about the word associative. So when I taught 8th grade, the stems was a big deal in middle school. And so we talked about the stems for these words. I can see inside the word associative, I can see the word associate. So your associates, those are the people that you work with. In 8th grade, I told them those are the people you eat lunch with. Those are the people you play basketball with. Your associates are the people you hang out with. So the associative property says the numbers can change who they choose to hang out with. So here I've got A and B hanging out together. Here I've got B and C hanging out together. It doesn't matter if I add A and B first and then add it to C, or whether I add B and C first and then add it to A, I get the same answer either way. So who numbers choose to hang out with doesn't matter. Now, one thing to be watchful for this one, and some of your students will make this misunderstanding, just because you see parentheses doesn't mean it's necessarily the associative property. You have to watch the numbers. Look, A, B, C, A, B, C. The order of the numbers did not change. Only the grouping, only who they're hanging out with changed. So just help your students to be watchful of that. Okay, here I have the identity property. The identity property is 0. The additive identity there is 0. And the identity property says if I take any number and I add the additive identity, it doesn't change the number. It retains the identity, quote unquote, that it had before. And commutative property says I can do the number plus 0, or I can do 0 plus the number. I'm going to get the same answer either way. The identity of the number does not change, so therefore this is called the additive identity. All right, so let's do some practice. I want you guys to see if you can figure out which property is illustrated in each of the following. Okay, so for this one, 5 plus 7 equals 7 plus 5. What property are we looking at here? Hopefully you put commutative property because the numbers are moving, right? Notice the T there, commutative. 5 is first, and now 7 is first. All right, this one says if I add together 1001 and 733, I get a unique whole number. That's the closure property. That number exists, it is itself a whole number, and that whole number is unique. So that's the closure property. Okay, how about this one? 3 plus 5 plus 7 with the parentheses here. 5 plus 3 plus 7 with the parentheses here. Did you catch my trick? That was the commutative property. Notice the order of the numbers changed, 3 plus 5, 5 plus 3, but who the numbers are hanging out with did not change. 3 and 5 are associated. 3 and 5 are still associated. They're just in a different order. So that is the commutative property, even though you see parentheses. All right, how about this one? 8 plus 5 plus 2 equals 8 plus 5 plus 2. All right, that one is the associative property. Notice that the grouping changed. 8 and 5 are hanging out, and here 5 and 2 are hanging out, but the order 8, 5, 2, 8, 5, 2. The order did not change. All right, m plus 0 equals m. That's the additive identity. So 0 doesn't change the identity of the thing it adds to, so that's the additive identity. All right, how about this one? Last one. See what you guys think. That one is the associative property again. I have reassociated. Here I have 4 plus 3, and here I have 6 plus 4. But the order 6, 4, 3, 6, 4, 3 has not changed.